In this video, I'm going to show you how to prove trigonometric identities. I'm going to do so by showing you a bunch of examples. If you'd like to be a master, you can pause the video at any point and try and solve some yourself before seeing how I approach it. With that said, let's begin. Question number 1. We have cotangent theta over cosecant theta. We want to show that this is equal to cos theta. Now, the left side is the more complicated side, so that's the one that I'm going to start with. The right side, I can't simplify it any further, it's just cosine theta. I'm going to simplify the left side by writing each function in terms of sine and cosine. So on the top, cotangent is cosine theta over sine theta. And on the bottom, we have cosecant, which is 1 over sine theta. Now, the way we divide fractions is we multiply by the reciprocal of the fraction on the bottom. So on the left we have cos theta over sine theta multiplied by sine theta over 1. The sine thetas cancel out, and we're left with cos theta over 1, which is just cosine theta. And this is indeed equal to cosine theta, so we have verified the trig identity. Let's move on to another question. Number 2. We have cos squared theta times tangent squared theta plus 1. We want to show that this is equal to 1. Now, the right side is as simple as you can get. It's just 1. So the more complicated side is the left side. That's where I'm going to start. I'm going to do so by writing everything in terms of sine and cosine. So cos squared theta, tangent squared theta is going to be sine squared theta over cos squared theta plus 1. And now I'm going to distribute the cos squared theta to both terms inside the parentheses. This is the distributive law. The cos squared theta cancels with the 1 on the bottom for the first term, and I'm left with sine squared theta plus cos squared theta times 1. That's just cos squared theta. Is this equal to 1? Yes, it is, because this is because one of the trig identities is sine squared theta plus cos squared theta equals 1. So we have 1 equals 1, and this verifies the second trig identity. Question number 3. We have 1 minus cos x over 1 plus cos x. We want to show that this is equal to cotangent x minus cosecant x squared. Now the left side is, I don't believe I can make progress that easily. So I'm going to start with the right side. We have derived trig functions, cotangent, and it seems the right side seems more complicated, so that's the one I'm going to start with. So I leave the left side as it is, 1 minus cos x over 1 plus cos x. And I'm going to write everything in terms of sine and cosine. So cotangent x becomes cos x over sine x minus cosecant, which is 1 over sine x squared. I leave the left side alone, 1 plus cos x on the bottom. And now I'm going to combine these two fractions by subtracting. They both have the same denominator, so we don't have to do anything fancy here. The denominator stays the same, and the numerator is just going to be cos x minus 1. Cos x minus 1 squared. Now, because the right side is squared, I can introduce a negative sign here without changing the right side, because negative 1 squared is just 1. So I can include a negative sign here. And the point is so that I can make the numerator on the top here the same as here. If I distribute the minus sign, I get negative cos x plus 1, which is the same as 1 minus cos x. So 1 minus cos x over 1 plus cos x on the left. And on the right, I have 1 minus cos x over sine x squared. 1 minus cos x over 1 plus cos x. And now I'm going to square both the numerator and the denominator. So this is 1 minus cos x squared over sine squared x. And I could expand the numerator, but that's just going to make it's just going to make it more complicated. So I'm going to. So from here, you can see that the left side is only in terms of cosine. So my goal now is to write sine, is to see if I can write sine in terms of cosine as well. And I can. It is 1 minus cos squared x. Now, everything is in terms of cosine, so the left side should equal, the fact that the left side is equal to the right side should be more apparent. 1 plus cos x on the left. And now, the denominator is a difference of squares on the bottom. This is 1 squared minus cos squared x. And the point is that the bottom can be factored. This is on the bottom 1 plus cos x multiplied by 1 minus cos x. On the top is the same, 1 minus cos x squared. And we have two factors of 1 minus cos x on the top, so one of them cancels out with this one on the bottom. And we are left with 1 minus cos x over 1 plus cos x equals to 1 minus cos x over 1 plus cos x. This proves the trig identity that we started with. It was longer than the previous two. But let's continue. Question number 4. What shall I do here? Let's do this one. 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals, or does it equal to, 2 secant squared theta. All right, so which side do we start with? I'm inclined to start with the left side because we have two terms, and on the right side we just have one term. So I'm going to add the two fractions on the left side, and I do so by multiplying each of them by 1. Multiplying by 1 does not change them. The point of this is that I'm going to make it so that they have the same denominator. So this 1 here on the left side is going to be 1 plus sine theta over 1 plus sine theta multiplied by 1 over 1 minus sine theta plus 1 over 1 plus sine theta times 1 minus sine theta, 1 minus sine theta. Does that equal to 2 secant squared theta? All right, so now to multiply the fractions, I just multiply the numerators and denominators. So for this first fraction here, it's going to be 1 plus sine theta on top. And on the bottom, it's going to be 1 plus sine theta times 1 minus sine theta. And the second fraction here, it's going to be 1 times 1 minus sine theta. That's 1 minus sine theta over 1 plus sine theta over 1 minus sine theta. Does this equal to 2 secant squared theta? These fractions both have the same denominator, so now I can add them. I can combine them into one. So this new fraction will have the same denominator, 1 plus sine theta times 1 minus sine theta. And on the top, I'm going to have 1 plus sine theta from this first fraction here, and then plus 1 minus sine theta from the second fraction. And now I combine like terms. The 1 adds to the 1 on top to give 2, and the sine theta cancels with this one. So I'm left with 2 over, and on the bottom here, I'm going to expand or use FOIL to multiply this out. So 1 times 1 is just 1, minus sine theta plus sine theta, and then minus sine squared theta. Is this equal to 2 secant squared theta? Well, so on the bottom here, I can rewrite this as 2 over cos squared theta. Is this equal to 2 secant squared theta? And the answer is yes, because 1 over cos squared theta is secant squared theta. So 2 secant squared theta does in fact equal to 2 secant squared theta. And this proves the trig identity. All right. Moving on to question number 5. What do we have here? Let's try this one. Secant to the 4th theta minus tangent to the 4th theta over secant squared theta plus tangent squared theta equals secant squared theta minus tangent squared theta. Or does this equal to secant squared theta minus tan squared theta? Now, the top here is a difference of squares pattern as well. This is secant to the raised to the 4th minus tangent raised to the 4th. 4 is an even number, and we're subtracting, so we can factor the top here on the left. So we're going to start by simplifying the left side. The top can be written as secant squared theta plus tangent squared theta multiplied by secant squared theta minus tangent squared theta. Is this equal to secant squared theta minus tangent squared theta? Now, this factor of secant squared theta plus tangent squared theta cancels out with the one on top. So this was actually very simple. Secant squared theta plus or minus tangent squared theta is in fact equal to secant squared theta plus minus tangent squared theta. And the trig identity is proven.